This is the video for the IPv6 addressing. So, um, important. The agenda of this video is to cover important things to take note in the IPv6 addressing. So let's start. So again, there's a new version of the IPv6, IPv6 address. They came up with the IPv6 address to um, specifically support our internet infrastructure. It's a much scalable protocol. With IPv6, it can support undecillion. That's very many. That's very is that the right word? It's there's too much IPv6 addresses out that are there. There are many combinations that we have in the IPv6 address. So let's start. Okay. Very important are the details. No, like first, again in this addresses very important yung mga number of bits. Example, if you remember, like MAC address is 48 bits, IPv4 is 32 bits, IPv6 is 128 bits total. Okay, 128 bits total. Take note of that. Next is its format is in hexadecimal. Okay, hexadecimal format. Okay, so the way an IPv6, sorry, the way IPv6 address looks like is this, no? So uh, it looks like this. So let's say 2001 colon 000 colon say 1234 5 4 5 6 7 say AAAA BBBB. So there, ano, there are um, four hexadecimal digits, and we call this as field. Okay, so we call it as field, and there are eight fields. No, let's first count: one, two, three, four, five fields. Each field is separated by a colon. Yes, colon. So each field is separated by colon. I got lost there. So again, let's count. One, two, three, four, five, six. So we still need more. So say say BBB2, and then um, DF. Okay, there. That's how an IPv6 address looks like. Okay, again, 2001 is a field. We called it as a field. Okay, each field has there are um, so IPv6 has eight fields. Okay, there are eight fields, and in each of these fields, it has so each field has four hexadecimal digits. These are things you need to take note. Okay, and in terms of number of bits, there are 16 bits. Okay, so since there are 16 bits, each number has 4 bits. 4 bits, ano? 4, 8, 12, 16, ha? In terms of binary. Okay, things to take note. Okay, so, uh, okay. Next in my agenda is it's lengthy, right? It's very lengthy. So they came up on ways to simplify IPv6. There are different techniques to simplify IPv6. So let's consider. Actually, there are only two rules. The first rule is to you can eliminate non-significant zeros, significant zeros. We were taught during our elementary days, say for example, if you have 0010, you can write this as 10, right? A 0010 can be written as 10. You can eliminate the zeros, the two zeros on the left side, but they are non-significant. They don't have any meaning. So same thing here. Okay, so let's have an example. Say for example, let's say I have an IPv6 address of say 2001. Okay, I'll have a say 0010 colon sorry, colon 011. I may got lost. And then there should be only four. Change this. Okay. Uh, I'll make it closer. Okay. Closer pa. Okay, there. Closer pa dun sa other. I think better if I can. No, no, later, sorry. So again, I'll just continue. Say 0000. Okay. Patience is a virtue. Next. 000. Okay. And uh, okay. I think that's okay. How many is it already? One, two, three, 4, 5, 6, 7. I only need one more. So 0013. There. Forgot the colon. And then to make them close, I will have the auto-fit column. So I have this given here. Okay. 2001, 1, 2, 3, 4, 5, 6, 7, 8. There should be 8. So if we were to simplify this, okay, so we can say that this is equal to, so 2001. So this um, 0010, we can represent this as 10. That's how it is. Okay, it is equivalent to 10. There. Okay. Make this left aligned. There, okay? So 2001 colon 10. How about this one? We can represent this as 110, right? We eliminate this 0 over here, okay? This one, we can represent this as 0, only 0. Okay, 4 zeros can be presented as colon 0. And this one can be presented as 2, 3, 4. And then for this is can be presented as 0, and then this as is cannot be simplified, and then for the last one, colon 13. There. Okay, oops. Colon 13. That's how it is, ano? Okay, if you were to eliminate the non-significant zeros. That's how it looks like. Okay? So, next uh next rule is um, uh, consecutive. If you have two or more consecutive zeros, uh, it can be presented as double colon. Okay? Double colon. Double colon. That's the rule. Okay? And then, one thing to take note here is that um, you can only use double colon once. One time lang siya pwedeng gamitin, okay? So, let's have an example. Say I have 2002 uh, colon of 0000. Ay, wait. Colon of 0000. I'll copy paste this ha. I'll just drag this. Ay, ano ba yan? So, 0. And then, I'll make this 0, 0, and 0. So this is my example, no? So I have this IPv6 address here. Okay? So let's simplify. So I can write this as 2002. If you notice in here, I have two consecutive zeros, right? This one, they are consecutive, right? For one group of zeros, another group of zeros, consecutive, ano, continuous. Okay, I'll have a highlight. This, you can present this as, it can be presented as colon, colon. That's what it means. Okay, colon, colon. So, and then this one, again, same. This, you can still apply this rule here. So, 0002 can be represented as 2, colon 2. And then this one, this can be presented as colon 3. And then this, can it be grouped? No. You can only use double colon once. Double colons once. Okay, there. You can only use it once. So I have already used double colons here. So with this, I can just say that this is 0. This one is also colon 0. And this is a colon 0. That's how it is. Okay, if I were to again write it, just to be sure. So that is 2002 colon, colon, colon. Okay, 2. Okay, okay. So again, this is colon colon already, okay? So colon colon 2 and then colon 3, colon 0, colon 0, colon 0. Oh, sorry. Colon 0. Uh, there. Okay, that's how it is. Control X. I just want to make it align. I think better to just write it here. There, ano? I think that's okay already. So this is the answer. I'll have a different color for that. There. Let me just double check. Colon, colon, colon 2, colon 3. Okay, there. So, can I apply double colons here? Yes. Okay. So, for example, again, so we have this given. I'll just use this side here. So, there's another answer, acceptable answer. So, and that is, um, you may apply the double colon on the last part. So, this will be a colon 0. Okay. Ni-merge ko. So, call C. Eh, So, you may represent that as colon 0 and then colon 0. And then in here, this is where you will apply the double colon. So, this can be presented as double colon. That's how it is. Okay? So, the answer is like um, 2002 colon colon 0 and then colon 0 colon 2 colon 3 and then this is where we apply the double colon. Okay, that's how it is. So that's one example. Okay, let's say I have another. I'll just copy paste this. So for example, let's say I have another here. As long as it is consecutive, it can be presented as a double colon. Okay, example, let's say I have here again, example, this one is a 0, this one is also a 0, and then let's say this one is a colon 1. So as long as it is consecutive, okay, I'll just use another one, say 2003. So I have another example here. So how do we simplify this? So I have 2003, and if you notice is these are all consecutive, right? So you can represent this as double colon. So this can be represented as double colon, and this one, the last one, can be represented as colon 1. So therefore this is equal to 2003 colon colon 1. That's how it is. Okay, 2003 colon colon 1. Okay, There is this IP address, no, there's this IP address, IPv6 address, wherein it's all zeros. It's equivalent to an all. Ano, it is equivalent to all zeros also in IPv4. Okay, IPv4. So example like this one, I have here uh, a range of all zeros. So 1, 2, 3, 4, 5, 6, 7, and I have another 8. Okay? So these are all zeros. So how do we simplify this? So that is equivalent to a colon colon. Okay? And then this one I forgot to add. This is equivalent to 2003 colon colon 1. Okay, there. Oh, so those are the answers. Then make this as blue. There. Okay? Very important, the simplification technique. If you were a little bit confused, better you review this video. Okay? So there. Anyway, there's only two, again, technique. Again, eliminate the non-significant and then apply the double colons if there are two or more consecutive zeros. And you can only use it once. Okay? So, next. Next in my agenda is details you need to take note about IPv6. And my technique of knowing what are there in IPv6 is by comparing it to IPv4. So we'll have a comparison here. Okay, so IPv4 versus the IPv6. Okay, so I'll make this center and bold. So like for example, IPv4, right? If you remember, there are 32 bits in IPv6. How many? 128, right? You guess it right. It's here. We've discussed it a while ago. Another is uh, page center. Another is the format, right? IPv4 is in 4 dotted decimal, while IPv6 is in hexadecimal. Okay, there. Next is take note that IPv4 has two parts, right? Network part and the host part. In IPv6 is the same. There's also a network part. We call it as prefix. And then it has also a host part. We call it as interface ID. Okay? Uh, and then in IPv6, the default is the prefix is 64 bits. The interface ID is 64 bits. Okay? We will discuss that in the PowerPoint part of the IPv6. Another, in IPv4, we have this what we call a subnet mask, right? Subnet mask. In IPv6, we also have a subnet mask, and we call it as prefix length. And the typical is slash 64. Right? In IPv4, it varies based on the class, right? As we discussed. Okay? Slash 8 for A, slash B for 16, and slash C for 24, slash 24. In IPv6, there's no classes. It only has one, slash 64. Okay? Uh, Next is the modes of transmission. In IPv4, if you remember, we have this term unicast, multicast, multicast, and broadcast. Okay, broadcast. Sending it to all. Multicast is sending to a group. Sending to a specific destination is unicast. In IPv6, there's still unicast transmission. Okay, sending specific to the destination, that's unicast. There's also a multicast. Okay, but it doesn't have any broadcast. There's no broadcast. They have removed broadcast. Okay, so we do not cannot see a broadcast address in IPv6. But they have this anycast term, one to nearest. Okay, there. Uh, Next is IPv6 has this concept of a link local. Okay, so it has this link local address. Link local is things to take note in the link local. I'll have it here, okay, a separate one for the link local IPv6 address. Uh, Things to take note in the link local IPv6 is this is an IPv6 address used to uh, connect or communicate within the network. It's a sort of a an IPv6 an address for within the network for the local area network. Okay, uh, and next thing to take note is that this is auto-generated, and when our operating system generates a link local, it always starts it starts with FE80. So if you see an FE80, that is a link local address. Okay, there, link local. Okay, in IPv4, with routers, there's also a link local for IPv4, but I will not be writing it here. No, I'll just have it here, the link local for the IPv6. Let's uh, let's go back. Let's go here. No, I have this simple topology here. I have never set up in my anything in the computer in the end device, but if you notice, if I go here to the desktop, there's that link local address. Oh, you see that, and there's already a value here. Okay, it's auto generated. The this device the device the operating system specifically generated a link local. So in reality, Windows generates a link local IPv6. Starting Windows Vista, there's already an IPv6, and by default, IPv6 is enabled. So automatically, Windows generates a link local IPv6 address. If you notice, it starts with FE80. Okay, there. And it's a working IPv6. Like PC0, PC0 can like connect or can example there are applications that they can work together that can be used already by these two computers to the network because they're connecting already with the link local IPv6. You see how there's already a reply. Okay, there. Okay, so uh, so far those are my inputs for the link local. Next is hmm, loopback. Loopback IP address. In the previous discussion we had, we said that there's that loopback IP add. Value is 127.0.0.1. It is used to test the TCP IP stack. In IPv6, it's equivalent to colon colon 1. Okay, colon colon 1. Next is we have these private addresses. Okay, private address and public, right? So again, there's the private and then there's the IP, public IP address. Okay. Uh, Private IP again are standards where we say, okay, we are asked that if we were to assign IP address for our computers in order for us to connect to our network, to our local network, can we assign any? No. Okay, can we assign 1111, 1112? No. By standard, you have to conform with the private IP address that your IP address assignment should be within the range of a 10. Okay, 10.00, the 0.0.0 up to 10.255.255.255, or a 172.16.0.0 to 172.31.255.255, and a 192.168.0.0 up to 192.168.255. Okay, it should be within this range. These are again what we call as private IP add. Okay, so again, if you were to assign IP add, example at home, you are to connect your your computer and computer of your siblings. You cannot assign 1111, 1112 to your computer. It should be within this private IP address range. Okay, because IP address that are not in the range, that are not in this range, yung mga 1, the 1111, 2222, 3333, those are public IP. So if it is not a private IP, it's a public address, and these are the addresses we have in the internet used by telco as a being thrown to our computers who wants to connect in the internet. Okay, that's the concept. Maybe some of you might notice that uh, I noticed that PLDT, when they gave me an IP for my connection, their assignment is 172.17.1.1. It's a private. Okay. Um, Others, that what we call as a NAT, network address translation. So what's happening there is because maybe PLDT, for example, has a limited number of public IP. So what they do, they assign private IP first to your computer, and then NAT will happen on their part. Okay, there. But by concept, public IPs are those IP addresses being assigned to our computers in order for us to connect to the internet. So again, this has something to do with internet. Public IP, private is for local. In IPv6, there's this term unique local. Unique local. So that is equivalent to private address, private IP. Its range is it starts usually with FC000, FC00 to FDFF. Okay, and then with public IP, there's this global unicast address. Usually there's this 2000. It starts with usually with 2000 starts. Usually it starts with 2000 or 2001, 2002, so on and so forth. Okay, uh, etc. For you to know the complete list of those global unicast or public IPv6 addresses, you may Google that. There is a website where it displays all those global unicast or public IPv6 addresses assigned to regional internet registries. Okay, so again, you may Google, you may search this by typing in global unicast IPv6 addresses. The legit one is the website uh, by IANA, Internet Assigned Numbers Authority. Okay, so there. Okay, so if you notice here, let me go back here. So like here, in the IP address, so I have a link local here, and and PC0 is already connecting to PC1. I mentioned that, right? So why do I need to assign an IPv6 address here? So that IPv6 is a global unicast. So example, let's say 2001 colon colon 1, and this is for the subnet mask say /64. There, okay. Close. Let me assign another here. So again in here, 2001 colon colon 2, say /64. Okay. Uh, See this difference, ha? In IPv4, if I were to assign an IP address here, say 10.3, and then say 255, in IPv4, in the end device, we only assign a private IP. In IPv6, there are two IP addresses that is being assigned: a global unicast, public IP, and a link local, which is a private, sort of a private IP. And you know what, the unique local that I mentioned, unique local, phase out na to eh. Maybe I think because there's already a link local, somehow it's redundant to the role of the unique local. So, so again, this is for the private, and then this is for the public. Okay, so in IPv6, an end device has a private and a public. In IPv4, it only has a private. The public IP for IPv4 resides on the router. Okay, so the system here in the IPv4, if we want to connect on the internet, because of the default gateway, say example, default gateway is 192.168.10.1. What our computer will do is to pass it to the router, and then the router will change our private to public, and then it goes out to the internet. Okay, here in IPv6, so if we type yahoo.com, it will use this global unicast. Okay, uh, in IPv6, because it already has, each end device has a global unicast or a public IP. There's no NAT. There's that what we call as NAT. The one that I mentioned a while ago, it's a NAT where uh, when example again with IPv4, if you type yahoo.com, goes to the router will change the private IP to public IP, that's the NAT. In IPv6, there's no NAT. NAT is discussed in Cisco 2, Network Address Translation. Okay, so there, I think I'm done. Okay, uh, let me just merge this. I think wait, I still have another one. Okay, uh, next is, uh, next is the configuration. Okay, I'm already here, right? Let's first check this pan pala. Let's first check my assignment. So I have 2001 colon colon 2. So you know what? Same thing here, ha. When you assign also, like, just take note that the leftmost part, that's the network part, also has that concept that it should be same. And then the last one, the left, sorry, again, ha, let me repeat that. The leftmost part is like the network part, it should be same. And then the rightmost part is the host part, it should be different. So I have here, like in PC1, a 2001 colon colon 2. In here, in PC0, I have a 2001 colon colon 1. Okay, let's ping the 2001 colon colon 2. Okay, and there's a reply. Okay, so it means it's connecting there, 2001 colon colon 2. So ping supports IPv4 and IPv6. Okay. Configuration in the router. If you were to set up IPv6 in the in a router's interface, it's actually has the same syntax with IPv4. Okay. So for example, let's say I go to the G0 interface G0 and then assign IPv6. So syntax here is IPv6. So instead of IP address, you type IPv6 address. So IPv6 address and then the IPv6 address assignment. Let's say I will assign, so in here I have assigned 2001 colon colon 1. In here I have assigned 2001 colon colon 2. And then this, I say I will assign 2001 colon colon 3. Okay, so let's assign that. So IPv6 address 2001 colon colon 3 and then slash 64. Slash 64 is the subnet mask. Okay, and then no shutdown. And there, it's up. Okay, I already assigned a 2001 colon colon 3. Let's check if this computer here can connect to that IP address assignment to the router. And that's the router, 2001 colon colon 3. It's request timeout. You see, if you notice, the switch is still orange. If it's orange, it's still not functioning. We need to wait for that to turn into green. Okay, usually like it takes around 1 minute, around 50 to 60 seconds. And there's already a reply. Okay, so that's how you assign an IPv6 address in our router's interface. I am done. I am done for the IPv6. Okay. If you have questions with IPv6, you may address that during our live session. And we'll have packet tracer activity as well with the IPv6 address. This ends my discussion. Thank you. Keep safe. Together we learn as one.